Hello, my name is John Broadwell, creator of the open source Serial Wombat project and an embedded systems and medical device consultant. Give me a call if you need any help with those items. Today, we're going to be looking at our first finished project video using the Serial Wombat 18AB chip, a bunch of these 100 microamp ammeters, some custom PCBs that I created. Let's see, not him, he's decorative. An FTDI cable, a couple of markers, and a handful of Dupont jumpers, plus some laser cut plywood. So let's get started with that now. Okay, let's put together a proof of concept to see how this is going to work. We're going to drive this ammeter directly from the Serial Wombat's GPIO port. Normally I'm against driving inductive loads, which is what this is, directly from an I/O port, but I'm thinking that 100 microamps of current at 3.3 volts driven through high resistance probably is enough that the Serial Wombat chip's internal tiny protection diodes can handle that. And if I'm wrong, then eventually we'll have to replace the chip. So there's going to be 3.3 volts coming off of here. We want 100 microamps to drive this full scale. So we're going to use 30 kiloohms of resistance to get that 3.3 volts to 5 volt to 100 microamps full range. So I'm going to hook this up just in series with the meter. We've got plus over here, so we'll put it on the positive side. The Serial Wombat 18AB chip has the optional 3.3 volt LDO attached and has grounded the address line. I've soldered a 6-pin header into the FTDI connector. So we're going to be running this in UART mode, and we'll be driving that from a PC using USB. So I'm going to hook up pin 19 to the positive on this ammeter through the current limiting resistors. I'm going to hook up ground to the negative side of the meter. I'm going to hook up the FTDI cable to the Serial Wombat chip's UART connector and plug that into my PC. That'll give me power and communications. Okay, we're going to do a proof of concept now to drive the current using the Serial Wombat 18AB's PWM mode. We're using the WombatPanel application under Windows, which is an easy way to play with your Serial Wombat chip before you've written software. If you take a look at the index up here, there's a clickable link if you want to find out more about this software. So we will go to Open Serial, open the FTDI port, which I happen to know is on COM98. Wait a second, it's syncing up communications. And it found it. And we've got a version 2.07 Serial Wombat chip ready to go. So we'll right click on pin 19 and choose PWM. 1000 kilohertz, 1000 hertz PWM should be perfectly adequate. We'll hit configure. And from here we can drive the PWM back and forth. And we can see as we drive this to the right and to the left, driving it from 0 to 100% duty cycle, that we get very close correlation between the PWM here and the output on the ammeter. So that's interesting, and we could build something interesting out about that. But what I want is something that will show the power of my particular PC, which has 16 cores. Each core runs 2 threads, so 32 logical processors. So I thought it'd be fun to do something that took advantage of the Serial Wombat's ability to drive lots of PWMs at the same time. So we're going to put up 8 ammeters at the same time, each of which will average 4 of these logical cores. So now let's build something that looks a little bit more finished that we can use to create this project. So the ammeters that we're using I got on AliExpress for a relatively low price. Bought 8 of those guys. And Fortunately, there were nice dimensions that came along with that. It's a pretty well dimensioned part. So it's one of the things we're going to want to do is create a nice finished panel that we can put those guys into. So I took these dimensions and created a simple SolidWorks sketch using the SolidWorks dimensioning. Makes it easy to calculate middles and whatnot. And I exported that to an SVG file through DXF. If you're interested in how to go from SolidWorks to InkScape to a laser cutter, take a look at this video up here. So from there, I took that drawing, I made an 8-up copy and put it into a box, and we will laser cut all of these so that we have a panel that we can connect up our ammeters to in a neat manner. So let's import that now into the Glowforge. So I like how the project is going so far, but I would like something that's a little bit more aesthetic. And so I don't want these microamp displays here. So let's take this cover off. Let's cut us out a percent label. There we go. Now it says percent. And I don't feel like this meter is sufficiently dramatic for something that's just a fun project. So let's put a couple of color bands on here that imply that things are really getting serious if we get up to the 80 to 100 range. Mark that with yellow. And we'll mark this one with red. I've never been good at small motor skills. Fortunately, most of what I do now is either run on a printer or CNC. So I like that now. Ooh, yeah, that looks serious. Some stuff going on right there. All right, now we need some kind of a cool labeling for that. And so I got my Dymo label maker here. We'll click out a little bit of that. Do a cut here. Okay, so we'll mark this. We know there's going to be 3 CPUs each. Let's just make one in the middle for fun. C, P, U, and we'll make this one number 4 through 7, because we know we're going to combine 3 of them together. Dash 7. And we'll cut that off. Yeah, I like that. It's got kind of a Apollo 11 / 3 Mile Island / Back to the Future feel to it. Okay. And then finally, this is not effective long term. So I created these little PCB boards that fit directly on the back of that. that we can use a lock washer to make a good connection on. And basically I'm going to solder 3 10K resistors in here and put a set of headers on there so that I can use Dupont jumper connectors to put the thing together. I put 1 power and 2 ground so that I could daisy chain the grounds together, because there's only 4 ground pins available on the Serial Wombat breakout board that comes with the Serial Wombat 18AB chip. So I will put together a grand total of 8 of these, and then we'll put the project together. Okay, here we can see the final assembly. We've got all 8 of the ammeters in the panel. On the back, we soldered together 3 resistors, 3 10Ks on each of these circuit boards, added the headers, then put them all together with Dupont jumpers. So basically we have ammeter 0, 1, 2, 3, 4, 5, 6, 7, and they are each tied. The positive for each one through the resistors is tied to pins 12, 13, 14, 15, 16, 17, 18, and 19 on the Serial Wombat chip, which then goes out over the USB cable to the PC. Now let's try to finish the project by tying the software and hardware together. You'll see that I have here the Serial Wombat class library, which is available on GitHub. And if you take a look up here, there's a link to a whole nother video on this and how it works. And we're going to create a solution that has a console app and the Serial Wombat class library in it. And the console app is just going to be very, very simple. Basically, we're going to use System.Diagnostics and Serial Wombat, and we're going to instantiate a Serial Wombat chip. We're going to call begin on COM port 98. That's where my FTDI adapter is. We'll write out some stuff here once we know it's going. And then we're going to create a list of an array of meters, which are essentially Serial Wombat PWM outputs. And for each one, we will instantiate the Serial Wombat PWM output and call begin on the appropriate pin, so that meters 0 through 8 are on pins 12 through 19. Performance counter. This is a built-in .NET thing in Windows that lets you get information. I won't go into that. You should Google it. And essentially what we're going to do is we're going to initialize 32 performance counters for each of the 32 cores that are available on my system. We're going to wait a second. Then we're going to go into a forever loop. Every 100 milliseconds we'll come out of sleep. We will add up 4 cores and then write the PWM out to the PWM pin. So essentially we will get 4 cores, write them to meter 0, get 4 more cores, average them, write them to meter 1, get 4 more cores, and so on, until all 32 cores are represented across 8 meters. One of the things that I really like about this project, when I created the Serial Wombat chip and the open source firmware and all that, the goal really was to make it easy to do easy things and possible to do hard things, you know, to kind of borrow a phrase from Larry Wall and Perl. And I look at this and it's like, wow, you know, there's almost no real code in here. You know, we've got some white space and some usings, but, you know, we just declare a chip and tell it, hey, we want 8 PWM outputs, and we get them. So, you know, I just really love the way to which we were able to do something really cool in 47 lines, about half of which are directives and white space. So this is really what I was going for when we created the Serial Wombat chip. And, you know, I hope that you guys are excited about it the way that I am. One thing to note is that this file and all of the other files, the SVG to cut the laser, the Gerber files for the PCB that I created are available on GitHub, and there's a link to those in the comments down below. So, you know, ultimately the question is, does it work? So let's run our console app here. And it's getting ready to run and initializing the protocol and whatnot. And we will also bring up our CPU. And what it's doing here, you can see the values that it's writing out to the 8. I'll minimize that because we don't need to see that run. But we can see that some various stuff is happening. And actually, reading and writing to those performance counters seems to cause problems for the performance monitor and the task manager. So we'll just have to assume that what it is doing is correct. I don't know what I've done there to make the rest of the system. Perhaps there's a limited number of these available. I don't know. But anyway, so we do that. And so do we think it's proportional? Well, I've got Handbrake here, which is a program used to compress MP4 files. Got a file ready to go. It does a nice job pulling in a lot of threads. Let's start that up. Let's start that guy up. And we can see that he's doing his encoding. And we see most of these cores go all the way up to 100, and the meters move appropriately. So we now have shown that we have a hardware-based meter system that shows the performance of the CPU. I hope that you enjoyed this video. If you did, subscribe below. You know, you're probably already into the Serial Wombat chip stuff, but as you know, this is the best way to get updates of new firmware and new stuff that comes out. I would definitely appreciate a like if you want. And if you're just looking into the Serial Wombat chips, you can get them. They're available on Amazon. So if you have any questions or if you build this project, please leave me a comment down below. I love to know what people are working on. And until I talk to you again, have fun and keep making stuff. The Serial Wombat firmware is available on GitHub and is constantly being updated. Subscribe below so that you can see the latest features and videos that come out as we fix bugs and add new features. The Serial Wombat open source project was created by Broadwell Consulting Incorporated. Broadwell Consulting Incorporated provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485, as well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting. Support requests for Serial Wombat should be sent to help@SerialWombat.com and will be answered on an as-available basis. Also, feel free to leave your question in the comments below.